Okay, guys, so we have the last part for this section, which is called the double angle identities for sine and cosine. All right. Now, sine only has one formula. All right. So it's sine of 2x. All right. That's the reason it's called double angle, right? Because if you're going to treat x as your angle, when it's sine of 2x, you're doubling it. Okay. And then, so what that ends up becoming is then just 2 sine of x times cosine of x, all right? And then for cosine of 2x, all right, it has 3 different formulas. And the reason for that is you can use really any 3 of these in any way that you want, okay? So it kind of depends on the problem that you're trying to solve. One might be more beneficial than the other. It might be more beneficial to keep everything in terms of cosine. So then you would use the second one. Or it might be more beneficial to change everything in terms of sine. So then you might use the third one. Okay, so it all kind of depends on, what the problem that you're solving. Okay. Now, another thing you guys might see is say it was sine of 4x. Okay. Now think about what are you doubling to get 4x, right? That's really going to be sine of 2 times 2x. All right? Now if you look back at the formula, sine of 2x, right? I'm doubling x as my angle, okay? I'm treating x as the angle that I use. So that shows up here and then also here, right? Now, in this case, when I'm doing sine of 4x, I'm actually doubling 2x. That's the angle that I'm doubling. Okay, so when I do my formula, it would be 2 sine of 2x cosine of 2x. Okay, because that's the angle that you're doubling. Okay, you're doubling the 2x. All right, another example might be sine of 6x. Okay, what am I doubling to get 6x, right? Well, that's just 2 times 3x. All right, so whatever angle 3x happens to be, okay, I would write it as 2 sine of 3x cosine of 3x. Okay, so you just want to pay attention to, exactly what you're doubling to get your answer. Okay. Okay, so over here it says find the exact value of cosine of 2 theta, all right? So looking at the triangle, right, we have a side of 4 and 5, and then we're going to say that the other side, which we'll call the radius, is going to be what? That's going to be 41. So it's going to be root 41 is your radius. Okay, so it says cosine of 2 theta, right? Now we can use any 3 of these. Doesn't really matter. So just for purposes, we'll just use the first one. So we'll have cosine of 2 theta is the same thing as cosine squared of theta minus sine squared of theta, okay? Now, I'm sure you guys remember when we talked about this, you're really taking cosine of theta and then you're squaring it. That's how you're going to solve this. Okay, so what would be cosine of theta now? So cosine of theta would be 5 over root 41. All right, now I know that we have a radical there, but that's okay because we're eventually just going to square it. And then sine of theta is going to be 4 over root 41. Okay, so this gives me 25 over 41 minus 16 over 41. And then that answer ends up becoming, what is that? That is 9 over 41. Okay, and that would be your answer. Okay, now say you didn't use that formula. Say you used a different one. It should come out to be the same thing. All right, so say we do 2 cosine squared minus 1. Okay, so this is now 2 cosine of theta squared. So that's 2 cosine of theta, we said was 5 over root 41. So 5 over root 41 squared minus 1. So that's 2 times 25 over 41 minus 1, which is then 50 over 41 minus 1. Common denominator, gives you 9 over 41, which is the same thing that we got before. Okay. Now, I know it's not on here, but say it asked you for sine of 2 theta. So sine of 2 theta is 2 sine of theta cosine of theta. All right. So you got 2 sine of theta would be 4 over root 41 times cosine of theta, which is 5 over root 41. All right, so this is going to be 2 times 20 over 41. And then that'll give you 40 over 41. All right. So again, that's just practicing using the formulas based off of the triangle that you're given. Okay, number 8 says find the exact value of sine of 2 theta, given that cosine of theta is negative 2 over 7, and pi over 2 is less than or equal to theta, which is less than or equal to pi. Okay, so sine of 2 theta, we know is going to be 2 times sine of theta times cosine of theta. All right, now it says that theta has to be between negative pi, or between pi over 2 and pi. So that's got to go in quadrant 2. So that's negative 2 over 7, right? Cosine is negative 2 over 7. Okay. Now, what would that give you for the missing side? So that's going to be negative 2 squared plus y squared equals 7 squared. So that's 4 plus y squared equals 49. Y squared is 45. And then y must be root 45 or 3 root 5. All right, you're going to leave that positive because it's in quadrant 2. Y terms are positive in quadrant 2. Okay, so what would sine of theta now be? All right, so we know that theta would go there. Sine of theta is going to be 3 root 5 over 7. All right, so we're going to use this, and then we also need that. Okay, so we got 2. Sine of theta is 3 root 5 over 7 times cosine of theta, negative 2 over 7. Okay. So 2 times 3 root 5 times negative 2 is going to be negative 12 root 5 over 49. And then you can leave your answer like that. Okay, and then the last one for this section, we'll be trying to verify this identity. Cosine of 3x equals 4 cosine cubed x minus 3 cosine x. Okay, so what I'm going to do is I'm going to use the left side. Okay, and the reason for that is that I can rewrite cosine of 3x. I can make that a difference, right? I can make that 2x plus x, right? Now we just talked about what would be the some formula for cosine, right? So that's going to be cosine of the first times cosine of the second minus sine of the first, sine of the second, right? Okay. So that's just some formula for cosine. Okay, now what else can we do? All right, now I see that I have cosine of 2x, right? Now we just talked about a double angle for cosine, right? Now that one has multiple different identities that you can use, but look at what the other side is. The other side is just in terms of cosine, right? So what I'm going to do is I'm going to change cosine of 2x to be just in terms of cosine, all right? So if you look back up at the identity sheet, right, that's going to be the second one, 2 cosine squared minus 1. All right, so this is now going to be 2 cosine squared of x minus 1 times cosine. Okay, minus, now this is also a double angle. Okay, so we're going to make this 2 sine of x cosine of x times sine of x. All right, so those are the double angle identities. All right. Now, what else can you do from there, right? Well, you see that you have parentheses and you have things on the outside. So what I would do is I would distribute. So cosine times 2 cosine squared, and then cosine times -1, and then distribute the sine also to that term there. So you got now 2 cosine cubed of x minus cosine of x, okay, minus 2 sine squared of x cosine of x, right? Okay. Now, you're almost all in terms of cosine, right? You got cosine cubed, you got cosine of x, and then here you have sine squared, okay? So go back to the Pythagorean identities, right? What could you possibly change sine squared so that it's in terms of cosine, right? Well, we know that sine squared plus cosine squared is 1, right? So then what is just sine squared, right? So if you move the cosine squared over, this ends up giving you 1 minus cosine squared. Okay, so we're using the Pythagorean identities here. All right, and then I'm just going to keep distributing. So 2 cosine cubed minus cosine. Okay. Minus 2 cosine squared times cosine. 2 cosine cubed minus cosine minus 2 cosine x minus 2 cosine cubed. All right, so for that part, first I distributed the 2, okay, and then I distributed the cosine. Okay, now I'm going to distribute my negative. So 2 cosine cubed of x minus cosine of x minus 2 cosine of x plus 2 cosine of cubed. All right. Now I'm just going to look to put things together. So I can put 2 cosine cubed with 2 cosine cubed. Make that 4 cosine cubed minus cosine of x minus 2 cosine of x is then just -3 cosine of x. And you have your identity. Okay? So this is kind of putting everything together that we've kind of talked about at this point. All right, and again, the reason that I picked that double angle for cosine of 2x, keep in mind what's on the other side, guys. That usually should help you pick out kind of what identity that you need to use. Okay. So if you have any questions, let me know. Thanks.